So I'm going to talk about threat modeling and cloud applications, but really this is more about the cloud application side than the threat modeling side. There's a talk tomorrow. I think it's exactly the same time. It's 11:40. My colleague Mike Ware is going to talk more about the threat modeling process. Here I've got the threat modeling pieces kind of built into how we look at cloud. You know, one of the things about, so this talk is called Cloud Threat Modeling because our marketing guides wanted us to use the word cloud. It's a typical marketing thing, you know. So you have something, it's sort of almost related to it. As long as they can find that little bit of thing, you know, it's like, let's tie it to cloud because that's the hot thing. It really is more about AWS. I've been looking at cloud for about a year and a half, 2 years, something like that. And I've been a little disappointed in how cloud gets treated as this one sort of thing. You know, there's cloud, and then but as we've been looking at it, it turns out that there are many different flavors of clouds, and there's all sorts of different ways of looking at it. And in terms of getting down to a set of specific things that, as someone in AppSec, that you can actually work on, I think you have to get below that, right? And you have to start looking at the specifics of what type of cloud you're looking at, and then all the way down to the specifics of the platform. So this talk really is about that level of, you know, trying to move this conversation from the FUD level of, oh my God, you know, cloud is the boogeyman, you know, security boogeyman of this millennium, to, all right, well, how actually can we improve the security of applications that use cloud? Because it's going, you know, the cloud applications are going to be there. We have no choice. We just have to make them as secure as they can be, and from there we can do risk assessments to figure out then, you know, what are the risks. So one of the things that I find very useful is the NIST Cloud Framework. There are three big pools, and I apologize for this diagram because I just took it's just a, yeah, I don't know, it's the JPEG from their site. But the three big blobs are essential characteristics, the service models, and then the deployment models. Now, from an architectural standpoint, this is all you need to know about cloud in order to do your threat modeling. When I use architecture, it's like really it's a set of patterns. And so from the essential characteristics, so here it's like on-demand self-service, measured service. You know, these things help you differentiate an application that you have today from when that application moves to the cloud. So just like our marketing people like to, you know, associate everything with cloud that has at least tangentially related, I think what's going to happen is that you're going to see vendor products doing it as well as internal projects. I mean, how many of you guys have projects that are cloud related in your organization? Okay, so how many of those are small funded projects? See, one? Oh, okay. So you're not supposed to raise your hand. Okay, because the point is that if there's a big funded project, what happens? Everybody and his brother wants to get their little pet project associated with it because that's where the money is, right? So you, as a security guy, you're going to be going like, well, what, is this rewrite of this application, is that really cloud? So essential characteristics help you understand that. Okay. The service models, so they're software as a service, platform as a service, and infrastructure as a service. And it's really from left to right, from left to right, you're going from, you've got the whole application down to infrastructure services where you're buying computes, okay, resources. Now, if you're buying the whole application, I assume you guys are all AppSec guys, right? I mean, this is OWASP, AppSec, yeah? Right, our job is done, right? We got to turn it over to the lawyers because all of the controls that are going to go in place for a software as a service application, I mean, it's, you know, unless you're a lawyer, right, those are going to be all in the SLAs. Like, Mom wanted me to be a lawyer. I ended up an engineer. So she was pretty disappointed, but she's psyched now that this whole thing is coming in place because now I got to learn all this stuff about contracts and SLAs, you know. She's waiting for me to, you know, to apply to law school. Okay. At the other end is infrastructure as a service, where you're buying computes. All right, now we're starting to get interesting for us as AppSec guys. And that platform as a service, again, you're talking about the development environment plus the build environment. That's for me what platform as a service is. It's like, you think you've got the raw computes, AWS, think AWS as the infrastructure as a service. Platform as a service is like Azure, plus there's all these platforms as a service where it's like, you've got all the build environments that all are part of that, right? So the service model tells you, how much you have to worry about, right? Now the deployment models at the bottom, public, you've heard people talk about public, private, hybrid, community. Ignore community because I haven't seen any of those out there. When you see one, then you can worry about it. But for pretty much, they tell you who are your threats. Oh, I'm sorry, I'm not supposed to use that word. Because Cigital has this weird, okay, so we're in the middle of Lutheranism right here. Here in beautiful Minneapolis. I'm from the East Coast. Okay, so it's all Anglican out there, right? And I'm not going to get down to arguing religion with you guys. So I'm not going to argue about whether a threat is the person or a threat is the thing that happens that's bad. All right. It's just not a useful debate, okay? And I'm going to lose, all right? But so I don't know how many of you guys know like the derivation of the term AJAX for like. And it's not the cleaner. I'm talking about the technology stuff, right? It used to be capital A, capital J, capital A, capital X, right? It was asynchronous JavaScript. What? Oh, and XML. Okay, so in current, I can't even remember what it is, because now it's just like AJAX. So how many AJAX implementations still use XML? Small number, right? Backend stuff is all going RESTy. Okay? And how much of it's using JavaScript? Flash applications. They're different. They're different sort of client-side language options. So it went from this truly an acronym to just a word. So for me, the threat modeling thing is just a word. Okay, we're not going to talk about. I'll try to use the word attackers. I don't know about Mike. Mike may get into the religious debate, and he's free to do so. But approach with peril, my friend. In any case, everything you need to know about cloud threat modeling is on that slide. Okay? Why? Because from an architectural standpoint, and this is one of the things that I think is pretty interesting about some of the work we're doing at Cigital, is we think about architecture as this abstraction of designs, where you can identify a set of components and relationship of components, and some of the side effects and the vulnerabilities and the inherent flaws in those sets of components. Like for us, OWASP, really the open, the web applications are one of those architectures. N-tier, thin client with a browser. You can see the OWASP top, I don't know, the top 10, but all of the vulnerabilities are associated with those architectures. So when we look at larger systems where an application is one application in a series of cooperating applications, we can see, oh, this is an N-tier thin client, OWASP top 10, and all of those associated vulnerabilities get associated there. Oh, this piece over here, that's a thick client with an embedded kernel, da-da-da-da-da. That's a different set of vulnerabilities. Right? So we think of these things as architectures, and the architecture brings both a set of power, it brings a set of security controls, it also brings a set of baggage. Right? And the baggage are the vulnerabilities and the flaws. Right? So by looking at your cloud, dissecting it into these, taking a look at it from this perspective, you can start using that to figure out, well, what's the baggage that's going to come with this application as we move it to the cloud. Any questions? You guys are really quiet. Are you always this quiet? Where's the? I kind of.
Which definition of threat?
I don't. Yeah. No fair. Okay, so he's ex-Cigital. We booted him out. Okay, because he was such a. Yes. But anyway, Yeah, like I said, I'm trying to stay away from that whole thing. Like, don't ask me what God is or anything like that. I don't talk about this. Okay, so for us, cloud, the PaaS and the IaaS are the most interesting. They are subtly different. When you start seeing applications that are built on a cloud architecture, I mean, think about it as like saying, oh, let's think of an application that's built on Windows versus one that's built on Linux versus something that's built on a mainframe. You know, those are fundamentally different architectures. There are subtle things that are different because the security controls are different. And we think that this notion of threat modeling, looking at it at this level at the design level of as a set of components, is very useful and is a first order of understanding of what the problems are, and a very useful way of understanding the risks because they're at a high enough level that you can associate them back to actual risks. So I'm going to kind of go through the threat modeling basic stuff because I know Mike is going to do a much better job of it tomorrow. But in short, for us, a threat model is, there still is some debate around Ed's digital, even to this day. So he may say something different, and that's your carte blanche, Mike, to like completely contradict me. So anyone who's listening today, you should find some things where I contradict him and pin him to the wall tomorrow because I'll be interested in hearing what he has to say. Anyway, so it's basically, you take a system, you look at it, how it's put together, you figure out the assets, the things that we're trying to protect, it's data or function, and then the security controls that are protecting those assets. That's what you start with. From there, you juxtapose that view of the system with the doomsday scenarios, the things that could go wrong from the business side, and a list of potential attackers. You're looking at these two things, okay? And from there, you can kind of figure out a set of, like, what the hell can go wrong? This is Mike's slide. I'll let him discuss that tomorrow. And then that's just a picture. Just, you know. I don't know. The marketing guys, it's like, you gotta have pictures. So there is a process. So we talked about this diagramming the system structure. That's the first one. Identify the assets and controls, right? That's the first part, right? Here's the juxtaposition. You know, here's the enumerate doomsday scenarios and identify attackers. This little space in here is the juxtapose the two. And then from that, what will drop out of that is actually there's a set of misuse cases and abuse cases that are going to fall out of that. Right? Then there's iterate probably is up here because you're probably going to iterate to, well, yeah, 3 and 4 mostly, but you do tend to, as you go through this and you start digging into it, you start going, oh, I forgot about that thing. You know, I forgot about this little piece of data over here, or, you know, so you do iterate and you go forward. So any questions about threat modeling? I know that was a very quick thing, and Mike's going to spend a lot more time on it tomorrow. Cool. All right, so looking at AWS applications. We've been looking at a bunch. And the application this little sort of use case is one that's a generalization of several different applications across a different set of industries that we've looked at. Remember, we're looking for patterns because as a consulting firm, you know, our job is to go in there and get it done quickly. So we're looking for ways of making this run faster. And so that's why we look for patterns. So this is a hybrid infrastructure as a service threat model. So the deployment model is hybrid. So that's mixed data center and cloud and infrastructure as a service. Okay? So here's our use case. S3 storage is it's a big hunk of block storage. And who's using AWS here? Do we have any AWS? Oh, okay, excellent. So you guys are, oh, that's right, Will actually works for them. All right. Yeah, he's got the, that's true. He's got his tomatoes wound up. See, he wanted to be shortstop instead of playing in left field where Mike is, so he has a better throw, you know, home plate. Right? Okay. So S3, it's a great, I'm from Boston, right? So we're like Red Sox Nation, you know, we're totally into it. S3 is, large chunks of block storage, very cheap, well, relatively cheap, right? And so what we're seeing is that this use of S3 is very interesting from a business standpoint because especially where there are large chunks of data. So you can see, that medical images might be a large chunk of data. We see, large media files. We see it in terms of, game systems where there are large things, basically large chunks of either they're images. Actually, it's really in a game system. It's a mixture of images and content that wants to get downloaded onto the client. Right. For the medical images things, I think that disaster recovery becomes a very interesting case for S3 because in disaster recovery, if I have large quantities of data, I have to have a DR site that has all that same data. It means I have to replicate the data over there. I have to buy all the storage, right? Now, who here buys storage? Anyone buy storage? No. Okay. All right. So do you think I buy, if I'm buying 100 terabytes of storage, let's say that's what I actually have to store. That means I have to have another 100 terabytes over in my DR site, okay? Now, do you think I buy, another terabyte at a time? No, I'm dealing with whomever my storage vendor is, and I'm buying large chunks of it. So I'm buying two chunks, right? So the idea is if I can only buy one chunk using S3, then I can really reduce my overall capital outlay. I can turn some of my CapEx into OpEx, and that's, at the CIO level, that's the equation that's going on in their minds. Okay. So here's our primary, here's our DR site, right? So I don't have to pay for unused capacity. Okay, that's what they're thinking. Well, whether that's a fallacy or not, that'll be my next year's talk. Okay, but just think about how outsourcing went, right? Okay. So the idea then becomes, okay, well, let's not do this DR thing. Let's use S3 and let's put everything in S3 in the cloud. Let's put it in the cloud, right? And then we don't have to replicate it. Now, even if you even if you put it in the cloud is not this magical place. Okay? Does not provide. It provides some level of. I think Amazon especially provides some large number of nines of durability, but it doesn't provide availability with that same level of nines. I think it's 3 nines maybe. Okay, and if you were doing cloud stuff, I think it was it this spring maybe? I can't remember when that data center went down, right? Pardon?
April 21st.
April 21st. Yeah, see, it seems like so long ago. I mean, it was but anyway, yeah, I mean, so it went down. Now, if you look at the people that bought a single availability zone, they were only in that data center, those guys were hosed, right? But if you look at the people that bought the multi-availability zone feature, only 2.5 of those customers were hosed by that data center going down. So you have to you still have to do something. There's no free lunch, okay? So again, you got to know your controls here. So for a DR, make sure you have multiple availability zones, okay? So now you're starting to see that this, again, my point is that you've got to understand the platform. What does it give you? What does it not provide you? Because it's all the same. There's no difference between programming and building systems in the cloud than building it in your own data center. It's just that they're doing some stuff for you. No magic, but know what you're buying. Okay. Now, that's kind of an infrastructural view of it. But for me, the more interesting view is from an application standpoint. What does this thing look like? So I'm going to go from a very simple. I'm going to assume this is a very simple web app, just for argument's sake. They aren't, but it's good enough to know for this, because when you start looking at this new app, I mean, we're talking about fundamentally something different. We don't have this DR thing to worry about. We have to worry about this component here actually has very different characteristics than this data store over here. The DR components over here, where the storage lives, that's a high availability kind of application, right? We've now switched application types because we don't have this ability to go to DR. I mean, we know that it's going to shift, but we have different availability constraints and requirements. So now know that you have this whole new app. So now we're going to diagram the system structure. This is a very simplified view of our original app. You can see here that from a threat modeling standpoint, we've done some trust zoning. Sort of that's kind of a that's a different. The app server, the host. We've done some threat. Here are our malicious network attacker, our malicious client. The security controls we have here. We have auth and auth through SiteMinder. We have the file system here. So part of the threat modeling process is to go through. If you went back and you were to read slides, it says, oh, go through, identify the assets and the controls. Again, this is when you see the reason I did this all in one little slide rather than derive this is because we had an N-tier web app, right? These are the canonical things that fall into place. You see, if you say I have an N-tier web app, you've got the app server, the host, some database on the back end. All of this kind of comes in. That's part of the baggage. Right? All right. So what does this do to our threat model? So we start there. So now we have this whole other thing, right? So we have the AWS piece up here. We have our storage. This is the S3 thing. This is everything that we were trying to do is move all that stuff from the file system out into S3. But you know what? It's not quite that simple. Right? We're going to have, there's got to be this little database here that's keeping track of all the stuff that's up here. We have to have, this little application that makes these buckets available during the DR, because DR is not like that for an application like this, right? DR, you're shifting over, you're moving you're moving DNS entries. It's inherently a slow process. Now, if these are medical images, do you really want your doctor to go, oh my gosh, we have to wait for your image, in the OR? No, you want it to be, the guy wants the image, okay? You want him to have the image, okay? So you have to build all of this other stuff, right, in Amazon to make that stuff available during the DR process, okay? So now we've got more stuff to worry about. And so the new system, this system is going to affect AWS is going to affect the whole threat model. So we have the thing, I can't remember what we call this thing. It's like the threat traceability matrix. Yes? Yes. Awesome, okay. It's just I don't have little kids anymore, but when they were little, they used to come back and there was this who, what, when, where, how. I mean, they went through this phase. If you have kids, it must be around 6th or 6th grade maybe. They go through it. So it's who, what, when, where, how. Right, why? I mean, it's like writing, it's writing about, it's books, it's the English stuff. And that's what the threat traceability matrix is. So you're going to fill this thing, it's basically you're going to fill in this sparse matrix and you're going to fill it in as you go along in the threat modeling process. And there are things at different times, and so that, in the background, that's what's driving all this, is we're trying to fill this matrix in. Okay? So you can see up here, too, that with our external, we don't know who, but mostly they're external. But we know the how. Because we have a web app, we're going to have all of these things, right? We have all the OWASP ones that goes right into the matrix. And then we know, because this is a public cloud, remember, that was the deployment model. We know that we have it's a multi-tenant architecture, so we have those hows to worry about, right? Again, so that's why, like I said, baggage, once you start having these architectures, and you start seeing your systems as groupings of architectures, you can start filling in the matrix in big chunks. Okay, so where are the assets? We know we have the assets before, but here are the assets. We've got the S3 buckets, which have our data. We have this EBS volume now, which It's a little relational database that's keeping track of all these S3 buckets. We have this additional set of entry points here to secure, right? This could be a web application too, but we have all these things to worry about. Now, those are the assets. What are the controls? See, now below we had, our enterprise identity and access management guide. I just used SiteMinder because I couldn't think of what the other ones were. But that's not going to work necessarily over here, right? So we're missing this piece here. Instead of having network zones here, Amazon has these things called security groups. So they're like firewalls, but they're a little different. They're actually a little bit more interesting than firewall rules. And we still have our traditional, we have our security groups. They have to be applied to each instance, and we have to worry about, we still have the standard database RBAC over here. So again, right? So security groups, it's like a firewall rule, except you actually create roles. There are groups of rules that are named, and when you launch an instance, you actually say this instance has these security groups associated with it, which makes it very powerful because you can create sets of rules and launch instances with those different sets of rules. Right? So it's a little different, but they just look like firewall rules. So those are cool. So you need to know you have to do that for all of your machines. Now, the problem with security groups is because, especially as you go through development, you add machines, you're not quite sure. How many lines do you think, if you actually do EC2 describe, security groups, how many lines do you think you have in one of these files? 25, 50? No, like 200, right? So like firewall rules, management of them as your application gets hairy. It's also, you've got all of the old security group roles and stuff, all the experimental ones in there. So you got to make sure you get rid of those. Okay? So management of security groups, you could probably use whatever tools you're using to manage firewall rules with. Integration with Enterprise Auth. Okay, so I think the previous speaker talked about this a little bit, but your choices are, I can make my LDAP available to the cloud, which is a good or a bad idea. It's a pretty rotten idea, okay? So what are you going to do, okay? People do it. Like I said, we've seen some of these things. They make the LDAP available, bad. They make copies of all the users. They rip, bad idea, okay? All right. So I'm not going to get into that whole set of bad ideas thing here, but for this we're going to say we're going to use SAML, okay? Just wave our hands and make this problem go away, because that's a whole nother talk, okay? So we're going to use SAML, and thank God there's support for it in AWS, okay? There's some other features in AWS that we're going to take advantage of as well. All right. But remember that SAML, that's for your auth here, okay? That's for the SSO here, and for the identity federation here, not necessarily. There's a whole bunch of other identities that are going to come into play. Okay? So now here we have this thing. Now, the nice thing, I think if you go back to essential characteristics, there was one thing called on-demand billing, right? You actually have to pay for this thing, right? Unlike CapEx, where you pay for it once and you get to use it, you got to pay for this by the drink. So you've got this site running up here, which is used during the DR process. When that thing's up and running, the cash register is going ka-ching, 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 ka-ching. So your CFO is going to say what? Shut it down, right? When you don't need it. Okay, so okay, fine, so you shut it down. Now what problem has this created? Okay, so normally, when you launch an instance, you have to have a set of credentials to launch the instance, on all that good stuff, right? But now you need it to be automated, right? So now you have to put this EC2 key pair down here somewhere in your infrastructure. You've got to have a host that launches it, right? So now you have these credentials that you have, these EC2 credentials that you have to secure. EC2 credentials, let me just make sure I know where I am. Okay, yeah. So they're required to, so you need to, you need AWS credentials to access anything in AWS. So you have that problem all over the place. One thing I want to say about the credentials, though, and you can read here, this is a slide, this is kind of taken from the AWS thing. There's like lots of different credentials, plus there's this whole IAM thing. The bottom line, though, is, or sort of, not the bottom line, but kind of the thing that is at the bottom of the slide is who pays for AWS in your organization. Going back to our essential characteristics, it's on-demand, there's this thing called on-demand self-service. And what does that really mean? What is the, some architect wrote that, but what does that really mean?
You pay for what you use.
You pay for what you use. Actually, that's the payability, that's the billability thing. Exactly. So what do you think happens in your organization? Exactly. Random people spin up stuff. So being able to control those credentials, right, is something. So not only do you have to worry about it from a secure, sort of traditional software security view of I got to protect this credential material. There's also this problem now of what are the credentials that we're going to allow in the organization? Who's going to have access to them that can spin up these instances for these particular things? So going back to that little picture of saying that there's a host there that's actually doing that, that actually might be a good thing because that might be your show point to be able to say, this place has those credentials. You can actually do credential mapping from your internal, internal identification ID system, saying, Joe can spin up these images, this other thing can spin up these other images, keeping those AWS credentials that actually have the billing associated with it, keeping those secure. So that actually might be a way of componentizing that and isolating that. So you've got that problem to solve when you have AWS in the mix. Okay, so S3 and S3 buckets and ACLs. So buckets have objects, and those things have either ACLs or policies associated with them. When you make an access to the bucket, AWS identifies you based on your AWS credential, right? And the ACL will give you access to it, or the policy says this person has access to it. And you can see here that as long as we're going from our app server down here, making this call to get the bucket data comes back here and goes back to the client, right? So this dude is going to have the S3 username and account to get to the bucket. That's why there's a little star. That's the credential that we're going to have to protect. You can see here from our threat model, there's actually no protection on it right now, which is typical, right? Username and passwords in the clear, being stored, Right? So you have this. This is the control that's here at the bucket. Now, because you're paying for all this, if I'm bringing the data back through here, back to my user over here, I'm paying for bandwidth over here, right? I do have bandwidth over here that I'm paying for, but that's a fixed cost. But here, I'm paying for bandwidth here, and I'm paying for that on my EC2 bill, right? So the CFO is going to go say, we need to stop that. And these are like, if these are video things, you definitely don't want to keep sucking them back through all your infrastructure, paying for it twice actually. So what you're going to do is you're going to actually do this, or maybe you guys aren't, but your developers are going to want to do that, right? They're going to want to say the client itself wants to be able to make a call directly to S3 and suck that data back. You want to bring it right back without going through your infrastructure. So how do you do that, right? Are you going to put your S3 credentials on the client? Oh, sorry. Yeah? Well, fortunately, most of the applications we've seen have not gone there. The developers have realized that was a stupid idea. Okay? That's a good idea. That's a good thing. But what did they do instead? Exactly. Full read access to everything in here, because there's no ACL. So it turns out that they're coming. You're assessing this thing, and you go, okay, well, they're going to look at you when you say, well, you got to have an ACL there. Then they're going to say, well, what should I do? Well, the nice thing is that AWS has a couple methods for doing this. One are if you have ACLs turned on, there's this thing called query string authentication where you actually can get a timed-based URL. If you're using the IAM features of AWS, you can also use this thing called get federation token. I think that's the URL. I think that's the API call. Again, it's a time-based token, which this guy gives it to the client, and the client can use it, and it's time-based. So rather than creating some of your own lame brain scheme to do it, you got to understand, if you know what the platform gives you, your guidance to the developer is so much better. So it's really well worth going through and spending the couple days reading through all of the friggin' AWS docs, building your little applications. It really is worth it. I mean, your manager won't think so, but believe me, it will be. So, enumerate the doomsday scenarios. The other thing I always hated about the typical cloud security doomsday, talk is, at least last year, it's not so bad this year, but last year it was every possible security risk was associated with a cloud. I mean, so and it's really not. I mean, yes, those things do exist, but really what you want to start thinking about is what's unique to the cloud. So I started my list of things that I think are kind of reprioritized. I think so malicious insider, we'll talk about that one in just a second. Data in transit, certainly on AWS, you have to worry about, there's no secure network thing, so you have to worry about that. Management interface compromise. How many of your applications, how many of you guys are enterprise developers or security people? Most enterprise? So when someone builds an application, do they build a management interface to it? They do? Oh, that's cool. That's actually good. Usually it's like some command line thing, right? It's usually, he's laughing behind you, so he knows, he's like.
Well, they have both.
Yeah. Yeah, but I'm talking about, write this little Java program and, it's all hacked together. But, so they've got these little programs. Now, from an evaluation standpoint, do you evaluate the management interfaces and look at them from like what the threat model is for those? It's part of the app. Okay, so now where in a cloud-based application is that management interface? Is it inside the secure part of the data center? Oh, you're not saying touchdown. You're saying 10 minutes. Okay. I'm serious. Like it took me just a second. I was like, okay. So now, so your management interfaces now are going to be all out in AWS. They're out. I mean, basically that's the story, right? Infrastructure supply chain stability. So we've been talking a lot about AWS, and it's like you guys are consuming AWS, but if you consume a pass, a lot of these passes like PHP, fog, all these things, what do you think those are? What do you think they're built on? You're buying them, they're built on AWS, right? It's going to be pretty soon it's going to be someone else is built on this pass that's built on AWS. That's the supply chain I'm talking about, right? So you have to worry about that. And then, the typical, this is the multi-tenancy part, direct denial of service, or really against someone else, another tenant, right? So, but the unique to cloud is the termination of the provider. Yep. It's these e-discovery things. I think you were talking the previous thing talked about.
What statements does Amazon make publicly about email?
That I don't know. Will, what statements does Amazon make about?
I'm not here to speak, but on behalf of my employer.
Yeah. Actually, I don't know. That I don't know. And then changes in, and then, you know, again, the jurisdictional changes, the e-subpoena of multi-tenancy. Those are the things that are unique to the cloud. Right. So identify the attackers. So we have all our canonical attackers. There's additional, you know, there's additional attackers here. There's, you know, that it changes where they are. And then from a diagramming standpoint, it's always good to have this multi-tenant thing here. So, you know, part of this thing is diagramming. It's always good to know where your multi-tenancy is. Now, really, the question I have is the AWS admin someone I have to worry about? So I mean, for the enterprise side of it, everyone's going, yeah, you have to worry about this. Right? So I'm going to give the counter argument, and you guys can decide for yourself. So the other side of it is that if I'm AWS or I'm Google or something like that, I have to have these admins. I have to train them. I have to manage them. I mean, part of what you're paying for is me to do that for you. So if I have a malicious admin who does something wrong to my business, who stands to lose more? You, the customer, or me, the provider? Probably you.
Yeah, because the admin would touch more clients, more potential clients.
But
just one.
Right. But if there's a provider, their argument, the other side of it is if there's a compromise of all these clients, won't Amazon get sued by all those clients? Won't their business? I mean, you know, what about the continuation of their business, right? So so I know that, I guess the point is the thought exercise of your business, your data versus them. I mean, that's really what it comes down to. So it's not the FUD of, oh my God, I don't control that admin. It's, what am I putting there? Who's going to lose more, him or me, right? Because it comes down to, that's a risk management decision. Now you're starting to think about it in those things. It's not just the knee-jerk reaction of, oh my God, I got to worry about the malicious insider. Right? Your malicious insiders may just be just as bad, right, and perhaps worse. And so,
You're saying that their logging and monitoring of their insiders are better than my logging and monitoring of my insiders.
maybe I'm saying that's their argument, and I think it has to do with size of your organization. If you're, I don't know how, I forgot to do the poll. I usually do a poll like who is in a large organization, who's in a small organization. But if you're a small startup, I mean, certainly, who cares, right? If you're United Healthcare Group, you care. You know, your loss is worse than theirs. Okay, so now we integrate with risk management. That's that. That's the only thing I say about that. That's the only thing I say because that's a huge can of worms, and it's an area that I know nothing about. I'm a geek, you know. I'm an engineer, so I try to stay away from all of this. That's that part. I try to provide all the information to those people who can make those decisions. Do the translation from this is this thing into this, and here's how it's going to manifest, and then go on my merry way and do my thing. So in conclusion, it's really I really think about this thing. The platform security proposals are really important. Understanding that platform and starting to treat the cloud like a platform, the way you treat any other software development platform, is really the key thing. Stop talking about cloud. Start thinking about, it's AWS. We're targeting, this other thing. It's the specific platforms. Now you can actually start figuring out whether or not your applications are at risk. You can start quantifying that risk, and you can start making intelligent decisions and having better guidance for your developers. So stop FUD, like get down in the dirt, figure out how it works. So thank you very much for coming. I'll be around if you have questions.